In this lecture, we will learn about the facade design pattern and how to implement it in Python. Facade is a structural design pattern. It hides the complexities of the system and provides interfaces to the client, using which the client can access the system. This design pattern provides a simplified interface to a library, a framework, or any other complex set of classes. We use the facade design pattern when we have a limited but straightforward interface to a complex subsystem. We use it when we want to structure a subsystem into layers. To implement the facade pattern, we first check if it is possible to provide a simpler interface than what an existing subsystem already provides. We declare and implement the interface in a new facade class. Then we make all of the code communicate with the subsystem only via the facade. If the facade becomes too big, we should consider extracting part of its behavior to a new, refined facade class. The advantage of using the facade design pattern is that you can isolate your code from the complexity of a subsystem. The disadvantage of using this pattern is that a facade can become a monolithic class that is coupled to all classes in an app. Sometimes this can be referred to as a God object, a class that is coupled with every other class in the application. Per the single responsibility principle, every class should do one thing and do it well. We want to avoid monolithic classes or God objects when writing code. Let's learn how to implement the facade design pattern in Python. We will start out by creating a class named facade. Inside of this class, we will implement the init function that takes in three parameters named self, subsystem1, and subsystem2 respectively. Inside of the init function, we will set self.subsystem1 equal to subsystem1, and self.subsystem2 equal to subsystem2. Then we will create a function named operation that takes in the self parameter. Inside of this function, we will create a variable named result, which we will set equal to the string facade initializes subsystems, and then the new line character. After that, we will append self.subsystem1.operation1, and then self.subsystem2.operation1 to the result string, using the plus equals operator. Then we will concatenate the string facade orders subsystems to perform actions to the result string, followed by self.subsystem1.operation2, and then self.subsystem2.operation2. Finally, we will return result. Then we will create a class named subsystem1. Inside of this class, we will create a function named operation1 that takes in the self parameter. Inside of this function, we will return the string subsystem1, operation1, with a tab at the beginning of the string. Next, we will define a function named operation2 that takes in the self parameter. Inside of this function, we will return the string subsystem1 operation2 with a tab at the beginning. Then we will have a class named subsystem2. Similar to the class we just wrote, the operation1 function will return the string subsystem2 operation1, and the operation2 function will return the string subsystem2 operation2. Next, we will create a class named client. Inside of this class, we will define a function named client code that takes in two parameters, self and facade. Inside of this function, we will print out facade.operation to the console. Time to test our code. We will create a variable named system1 and set it equal to a new subsystem1 object. Then we will have a variable named system2 that we will set to a new subsystem2 object. After that, we will create a facade variable set to a facade object with system1 passed in as the first argument and system2 passed in as the second argument. Next, we will create a variable named client, which we will set equal to a new client object. Finally, we will call the client's client code method and pass in the facade. As you can see, each subsystem performed its operations without the client directly accessing them, thanks to the facade design pattern that we used. In the next lecture, we will learn about the flyweight design pattern and how to implement it in Python.